Hypergeometric probability distributions are used when events are dependent on each other. For example, if you are playing poker and are looking at the probability of the next two cards containing an ace, other cards you have seen will change future probabilities. So in this example, if you have entered a lottery, there are 6 tickets sold total. 2 of them are yours. There are 3 tickets being pulled out of a hat. What is the probability exactly one of those tickets will be yours? So we want to know not if we can win. So you could do this twice if you wanted to determine if you win both of them or one of them. You'd have to do this with 2 and 1 and then add up your probabilities. In this case, we just want to know if exactly 1 is going to be ours. We're going to use our hypergeometric probability distribution formula. The formula is as follows. Okay, seems like a lot, but it's not so bad. S is our number of successes. And in this case, either one of our tickets being pulled would be a success. So that will be 2. X is the number of successes required in a sample. So we have 2 tickets, but we only require 1, and that's what we're trying to determine. So successes required within our sample, and that is going to equal 1, which is what we're determining. N, capital N, is our population size. And there are 6 tickets sold. 6. And small n is the size of sample. And there will be pulling 3 tickets. So knowing our variables, we can go ahead and enter and determine the probability of one of these tickets being ours. So the probability that x equals 1 equals 2 factorial divided by 1 factorial, 2 minus 1 factorial multiplied by 6. Oh, there should be a factorial there, sorry. That would be 6 minus 2 factorial. And we have 3 minus 1 factorial multiplied by 6 minus 2 minus 3 plus 1 factorial divided by 6 factorial divided by 3 factorial multiplied by 6 minus 3 factorial. So let's start working these down. 2 factorial is going to be 2. 1 factorial is 1 times 2 factorial, which is 2. So 2 over 2 for this section. multiplied by 4 factorial. And we have 3 minus 1 factorial is 2 factorial. 2 factorial is 2. So 2 multiplied by 6 minus 2 is 4, minus 3 is 1. So 2 plus 1 is 2, so 2 factorial, but 2 factorial is 2, because 2 times 1 is 2. 6 factorial divided by 3 factorial multiplied by 6 minus 3, 3 factorial. Now we can work this down even further. So we can eliminate 2 over 2, because 1 times whatever this will just be this. So we can go 4 times 3 times 2 times 1 divided by 4, 2 times 2, divided by 6 times 5 times 4 times 3 times 2 times 1, just divided by 3 times 2 times 1 times 3 times 2 times 1. And we can start working this out. So 4 factorial equals 24 divided by 4 is 6. Now 6 factorial, 6 times 5 times 4 times 3 times 2 times 1 is 720. Now 3 factorial, 3 times 2 is 6 times 1, still 6, and so 6 times 6 is 36. So 6, we just need to do this final calculation. 720 divided by 36 is 20. So 6 divided by 20 equals 0.3. 30%. So using our hypergeometric probability distribution, we have determined that if there are 6 tickets total and 2 of them are yours and 3 tickets are being pulled out of the hat, the probability of 1 of those tickets being pulled out is 30%.